piping systems of the modern nuclear submarine use thousands upon thousands of joints. These joints must be strong enough to withstand severe stresses in the piping during deep diving and the shock of depth charge attack, and leak-proof against internal pressures as high as 3,000 pounds per square inch. Brazing is an effective method of permanently bonding pipe to fitting. The brazing alloy is in the form of rings placed in grooves in the pipe fitting. When the assembled joint is heated, the brazing alloy flows, filling the space between the pipe and the fitting by capillary action. When it cools and solidifies, the alloy solidly bonds the joint together. A good brazed joint is strong, stronger in fact than the pipe or the fitting. However, brazing must be done carefully in a series of 4 steps. You must select the correct materials, prepare the materials for the brazing operation, braze the joint properly, and then clean and inspect the finished work. This film will show you how to perform these 4 steps for a good brazing technique. There is a wide variety of pipe fittings and brazing alloy, and brazing flux. Learn to identify each type accurately. Pipe and fittings should have identifying data clearly marked on the surface. Dots identify the brazing alloy rings. 3 dots for number 3 alloy, for example. Type B, low-temperature brazing flux, spec OF 499, is a satisfactory flux for almost all your brazing jobs. However, use type A for aluminum bronze materials. When making up a joint, it's essential that you use the exact materials called for by the plan. Double-check pipe wall thickness and outside diameter. The fitting must have a smooth exterior surface opposite the fitting socket so that ultrasonic tests of the joint can be made later. In many cases, the rings are delivered uninstalled in the fitting, although some fittings may have them already in place. When you double-check yourself, you're sure it's right. Prepare the pipe first. Scribe on the main section of pipe the exact length of the pipe to be cut off. A vibro tool is good for marking. Never use die stamps or electric arcs. Use as light a marking as possible, since sharp grooves weaken the pipe. Transfer all data from the main section of pipe to the piece to be cut. Record, plan, and joint numbers. When cutting the pipe, remember that a square cut is essential for the pipe to seat properly in the fitting. Use a ream or file to remove burrs. Check it and file it if necessary. Remove any nicks or ridges from the face of the socket that would prevent a good fit or reduce capillary action of the alloy. Do not chamfer the fitting. Try the fit. Smooth down any high spots in the pipe. The pipe should go in and seat without forcing and rotate easily, but not loosely. Check the fit with a feeler gauge, correct for the size of pipe you're using. If the gauge slides in, the pipe is undersized and needs expanding. Use the Wilson expander or equivalent tool. The rolls of the expander press against the pipe from inside when the mandrel is turned into the tool. The number on the mandrel tells you how much the pipe is expanded with each turn of the mandrel. After the expander is in the pipe, loosen the set screw and turn the mandrel into the thrust nut to bring the tool firmly against the pipe. While doing this, it's all right to hold the thrust nut from turning. Now, tighten the set screw in the mandrel slot and rotate the mandrel. This will roll the rollers against the pipe and correct any out-of-roundness without appreciably expanding the pipe. Now, loosen the set screw, and without restraining the thrust nut, turn the mandrel, remembering the number of turns you make. Make the turns you think are required for the needed expansion, then reassemble and gauge the joint. If more expanding is needed, again insert the tool. Turn the mandrel as needed. Then lock the set screw to avoid further expanding, and rotate the rollers several times for final rounding and sizing. Make a final check with the feeler gauge. You need to establish reference marks to make sure the pipe is seated properly in the fitting before and after brazing. Measure socket depth and add 1 inch. Lightly scribe the resulting distance or reference marks around the pipe at 3 locations. If the pipe is all the way in and bottomed, the distance will measure 1 inch from reference marks to fitting face. Sometimes, as in this case, you have less than 1 inch of exposed pipe. In such cases, choose a clearance distance that will leave the scribe marks visible after brazing. These reference marks are also used after brazing to check the finished joint. 2-inch IPS and smaller may be 1/16 of an inch from the bottom of the socket. From 2.5 inches IPS to 6 inches inclusive, 1/8 inch is allowed, although all the way in and bottomed is preferable in all cases. Now clean the pipe 1 or 2 inches up from the end with emery paper, stainless steel wool, or a steel wire brush. Follow with a wiping with acetone, alcohol, or water. On the inside of the pipe, clean about 1/2 inch from the end. Once cleaned, don't touch a surface with the hands. Clean the socket, including the face and the insert. Clean the alloy rings to bright metal and wipe. Install the alloy rings. Apply flux to all surfaces immediately after cleaning. It protects them from oxidation and scale and helps the alloy flow properly. Brush on the flux with a circular scrubbing motion, leaving no bare spots. Flux the socket interior and socket face. If the flux is lumpy, put the jar in hot water for about 10 minutes and work it smooth. The exception is copper pipe. In this case, wipe off the flux, leaving a light film. Experience has shown this will provide more even distribution of alloy. Assemble the joint using the reference marks. Add flux to the joint face. The action of flux is a valuable temperature indicator during brazing. If necessary, support the joint to avoid stress during brazing. If a joint can't be brazed within 16 hours after fluxing, disassemble it and reflux it before brazing. Fill out the quality control papers, and the job's ready for the brazer. Torch brazing is the most widely used technique of brazing. Your results will depend on your knowledge and skill. Begin by selecting the correct tip for the torch. The size of the fitting to be brazed and its wall thickness determine the size and pressure rating of the tip. Light the torch and adjust for a white flame. Yellow means too much acetylene, blue, too much oxygen. The flame should have a soft feather. A sharp, hard flame is too hot and may burn the work. Your basic objective is to bring the bonding areas of pipe and fitting up to the required temperature so the alloy will flow and cover the bonding areas. Since the entire fitting can't be brought up to alloy flow temperature at once, you must follow a heating plan. Heat relatively small areas, opposite each other around the circumference of the work, so the work will heat evenly. Hold the flame about 2 inches from the work and apply heat evenly to the entire fitting, and from 1 to 6 inches of the pipe, depending on pipe size. Since the fitting is heavier than the pipe, give it the most heat. Flanges have a tendency to draw off the heat because of the mass of metal, so heat the flange area first. There's always the danger of cracks around the bolt holes. Avoid this by being specially careful to heat the piece according to plan, so there will be no hot spots. The rule when using a torch on any kind of work is keep it moving in accordance with your plan. This will avoid hot spots and cracks. Don't let the flame touch the flux in the joint face. It will disturb the lay of the flux or burn it, oxidizing the metal. It may take quite a while to heat a joint of any type, so don't try to hurry it. Learn to judge temperature by using the flux as your thermometer. The water in the flux boils at 212 degrees Fahrenheit. At 600 degrees Fahrenheit, the flux itself boils up and begins to melt. At 1,000 degrees, the flux is melted and has a transparent look. As the temperature hits 1,100 degrees, the flux turns to a clear liquid. Above this temperature, the alloy, not the flux, is your thermometer. To raise the temperature above 1,100 degrees for the actual brazing, move the flame to within 1/2 to 1 inch of the work. Start at the top with horizontal work. The alloy tends to follow the heat, so heating the top keeps the alloy from puddling at the bottom. Grade 3 alloy melts at about 1,200 degrees and flows at 1,300 degrees. Don't get the work much hotter than this, or the alloy may run out of the joint. As soon as the alloy appears at a point, move the flame to a new area. Meantime, alloy also flows into the root of the socket. Work around the joint, bringing up the alloy all the way around. There may be times when there are gaps in the alloy. Any single gap in the alloy must be less than 10% of the circumference. All the gaps together mustn't exceed 25% of the circumference. If the alloy doesn't want to flow, use a wire of the same alloy you're using to apply a small quantity of the alloy. This priming breaks surface tension and starts alloy flow. After brazing a pipe that's 2 inches or larger, slow down the cooling by applying light heat to the pipe a few inches from the fitting, so the fitting will contract faster than the pipe. This will prevent the pulling away of the pipe from the fitting during cooling and contraction. Identify your work and fill out the control forms for use in maintaining joint control records. When torch brazing on the ship, precautions should be taken to assure that there are no explosive fumes present. Protect cables and exposed gear. Be careful not to damage nearby piping or equipment. Use a mirror and flashlight on hard-to-see joints to be sure the alloy is drawn out. Induction heating for brazing is a new development in brazing technique. At present, both high and low frequency generators are used for brazing shop and shipboard piping. The induction, or work coil, is placed around the joint, and an alternating electric current is passed through the coil. This electrical energy alternates at radio frequency and is called RF energy. As the RF energy flows in one direction and then the other, magnetic fields build up and collapse. The movement of the magnetic lines of force through the work induces a current in the work. The resistance of the metal to the current heats the metal. The coil is made of tubing. Water flows through the tubing, cooling the tubing. At the start of operations, warm up the equipment for 5 to 10 minutes by turning on the filament switch and set to proper filament voltage. Now adjust the work coil. Put 2 of the 3 turns of the coil around the fitting over pipe and fitting lands, since the heavier fitting needs more heat than the pipe. Center the coil around the work for even heating. Use asbestos paper, as it helps center the coil and prevents metal-to-metal contact between the coil and workpiece. Contact could result in overheating, arcing, and a poorly brazed joint. Set the temperature controller so the thermocouple causes the unit to shut off the power at the flow temperature of your alloy. Adjust grid and plate current to suit manufacturer's instructions. At 1,000 degrees, as indicated by the thermocouple, use the hand control to temporarily turn off the current. This will allow the heat to distribute itself more evenly in the work. When the temperature falls to 800 degrees, turn the power on again. As the temperature reaches 1100 degrees, the flux turns to a clear liquid, as in torch brazing. When the alloy reaches 1300 degrees, the thermocouple automatically signals the power to shut off. If the alloy doesn't appear, or is scanty, be sure the power is off. Then prime the joint with an alloy wire. Let the joint cool naturally. No post-heating is needed to slow down the cooling of an induction brazed joint. For induction heating aboard ship, the radio frequency generator is placed either dockside or on deck. Power is supplied through a cable to the remote matching transformer located at the brazing job on the ship. Even the most difficult locations can usually be reached with the work coil. Brazing procedures are as in the shop. Flux must be removed from all accessible areas of a joint since it corrodes the metal and may temporarily seal pinholes and voids in the alloy. If the flux is hard, keep drenched rags around the joint until the flux softens. Use a wire brush or scraper to remove flux. Never file or grind. Filing or grinding may damage the pipe or fitting surfaces. When the work is externally clean, your part of the job is done. Remember these simple rules for a good brazing job. Select the materials called for in the plan accurately and carefully. Prepare your materials properly. Braze the joint skillfully. Clean the finished work carefully. That's the way to be sure your work will be safe and reliable.